So now continue with photoelectric effect. Let's talk about intensity of light. Intensity, intensity of light. Of light. We know whenever a light is propagating from a source, it has two types of the things. It has two types. Okay, if we have a torch and you are lighting, so there are two types of property you can measure of a light. One is its frequency. What is the frequency? And one is its intensity. One is its intensity. So what is intensity? Intensity is energy incident on metal plate per unit area per unit time. So intensity is energy incident on metal surface on metal surface per unit area per unit time. It is per unit area per unit time per unit time. So it is, or we can say number of photons incident per unit area per unit time, or we can say number of photons incident per unit area per unit time per unit area per unit time. Energy incident on the surface per unit area per unit time. So intensity is defined as N into H nu. N is number of photons incident, where N indicates number of photons incident, and H nu represent it represents the energy of one photon. Energy of one photon divided by, in numerator we have area multiplied by time. So this is area of metal surface, and T represents here time. Okay, so we know N into H nu is a number of N, where N is the number of photons, H nu is the energy of photon. So N into H nu is total energy incident by photon per unit area per unit time. So we know increasing the intensity of light means increasing the number of photons. Okay, here if we are increasing the incidence of light, increasing intensity of light means increasing number of photons. That implements increasing number of photons, increasing number of photons. So frequency of light will remain constant, but here frequency, in that case frequency will not change. Frequency of light remains constant. We know when there is no relation between intensity and frequency. Okay, frequency represents the energy of light, and intensity represents the number of photons per unit area per unit time. So if we proceed further, we know I equals to N into H nu divided by area multiplied by time. Now N into H nu is force. It is the force divided by area per unit time. So it is pressure by area. Force per unit time is force per unit area is pressure. Okay, this pressure by area. So now if we talk about, so I equals to NH nu. NH nu is energy. Okay, energy. It is energy. Okay, now NH nu is energy, and energy by time is this power. Okay, this is power per unit area. So intensity is defined as a power. It is power. Okay, it is power per unit area. So now if we talk about the curve, in that curve, if we have a curve, here we have kinetic energy of photon versus intensity of light. So we know that whatever be the kinetic energy of photon, that will never depend on intensity of light. So we know for kinetic energy, frequency is constant. Okay, kinetic energy frequency is constant. Okay, kinetic energy depend on the frequency of incident light. Kinetic energy of photon. Okay, photoelectron. Okay, this is photoelectron. This is kinetic energy of photoelectron. Okay, so that is intensity of light will remain constant. Okay, because whenever metal surface has h nu, then h nu naught is the energy used here, and E naught and kinetic energy of photoelectron is E. So that only depends on h nu. Okay, now it is the very main important point. The very important point is that one photon interact with only one photoelectron, or interact, or we can say eject only one photoelectron. Means when you have a metal, when you have a photon incident on a metal, okay, whenever you have a photon incident on metal, that will interact only one electron will interact with one photon. Okay, means one photon only will eject one electron, and every time one photoelectron. Okay, we can say one photoelectron. We can never say like that it is useless. It will be in use. Whenever you are throwing one photon, one photoelectron will emit. That is sure. But only one photon will emit. Okay, when you are throwing one photon. So we know then that more the intensity of light. Okay, intensity of light we can also call as brightness. More Ni, more number of photoelectrons ejected from the surface, so more photocurrent. Okay, so let's say we have a two metal surface. Okay, and we have two metal surface. So in this two metal surface, suppose in first metal we are throwing suppose 4, 1, 2, 3, 4. We are throwing 4 photons. Okay, and in second plate we are throwing 6 photons. 1, 2, 3, 4, 5, 6, 7, 8, 9. Here we are throwing 9 photons. Okay, here we are throwing 9 photons. Okay, here we are throwing 4 photons. Here we are throwing 9 photons. So 4 photons and 9 photons. So what? So here, where the intensity is more, if we name it as, tag it as a first, tag it as second. So we know I2 is greater than I1. Here intensity is more because intensity is number of photons per unit area per unit time. So we know time is same. So there are 4 photons, there are 9 photons. So intensity of 2 is greater than 1. And we know 1 electron will eject due to 1 photon. Okay, here 1 electron will eject 1. So how many electron will ejecting? Here 9 photoelectron are ejecting. 9 photoelectron are ejecting. Here how many electron are ejecting? Here 4 photo electron are ejecting. Okay, here 4 photoelectron are ejecting. So where the current will be more, we know here current will be more. So N2 will be greater than N1. So if we draw a curve again, between photoelectric current between photoelectric current and frequency. Okay, this is frequency. Now frequency curve. Now suppose this is mu naught. Okay, this is nu naught. Okay, now we have obviously frequency should be greater than the desirable minimum frequency, that is threshold frequency. So if we have if we draw the curve, if then I2, where the photocurrent is N2, I1, the photocurrent is N1. So if we draw this curve, we know I2, the photocurrent will be more when the frequencies are same. Okay, when frequencies are same, then we are drawing the curve, frequency is same, but photocurrent in case of 2 is more than photocurrent of 1. So now let's talk about one more term, that is stopping potential. Okay, so stopping energy or stopping potential, that is stopping potential. So let's talk about stopping potential. So what is stopping potential? Okay, we have seen the photoelectron setup. So here we know when an electron, suppose in that photoelectric setup, suppose that electron is moving from the surface. Okay, so we have a voltage regulator here. we have a voltage regulator here. So in order to stop that electron, energy required to stop the photoelectron of maximum kinetic energy is called stopping energy, or the okay. So energy required to stop the, it is energy required to stop the to stop energy required to stop photoelectron, energy required to stop photoelectron of maximum kinetic energy, is called stopping, is called stopping energy, is called stopping energy. And the magnitude of minimum potential required, and the magnitude of minimum potential required is called of photoelectron of maximum kinetic energy is called stopping potential, is called stopping potential, is called stopping potential. Okay, now let's talk further. Now if we know when we have a charged plate, okay, when we have a charged plate, and that is positive charge, that is negative charge. So suppose V is the voltage spread over time. Okay, so if we have a charge Q, so what is the force on the charge is the force on the charge is Q multiplied by V. That is the energy of this charge due to V potential. Okay, this is the energy of this charge. So now in case of stopping potential, how much the energy the electron have, that is equals to kinetic energy. Here we know when in stopping potential the electron is moving from this direction to this direction, it has energy equals to kinetic energy, and that kinetic energy should be equals to the stopping potential, because we are stopping the electron. In case of stopping the electron, we need to apply the stopping potential, so it is E into Vs. Okay, so this we know in case of photo current, that is the charge. Okay, that is the kinetic energy, and how much opposite portion we have, Q multiplied by V. So here Vs is the stopping potential. V or not, or Vs is called stopping potential. It is called stopping potential. It is called stopping potential. So energy is now 1 electron volt unit of energy is equal to the work done of an electron according through the difference of 1 volt. So we know half mv square. The kinetic energy is half mv square equals to E into Vs. So E into Vs equals to h nu minus h nu naught. So it is equals to hc by lambda minus hc by lambda naught. So E into Vs, where Vs is the stopping potential. Okay, now this is the stopping potential, as we know that this is the energy required to stop the electron. Now we know value of stopping potential depend on frequency of incident photon and work function of metal. So value of stopping potential, we know the value of Vs depends on frequency of incident light, and work function of frequency of incident light and work function. Okay, the value of stopping potential of that is independent of intensity of light. That is independent of, independent of intensity of light. Okay, that doesn't depend on the intensity of light. The anode can be made positive or negative potential difference can be changed with the help of battery or restored. So anode can be made positive, negative. So if we see a curve, if this curve we see in this curve, suppose we have this curve. Okay, so now further, if we know that Suppose we draw a graph between photocurrent. If we draw a graph between photocurrent, okay, so now we know that when we have 2 versus positive voltage, and we know voltage can be regulated by restore with the help of battery and rheostat. We can change the sign. Okay, we can make the positive or negative potential difference. We can change the sign of potential difference. Okay, it could be negative or positive. Okay, so now if we have if we have the photocurrent is going, now we have a rheostat. Okay, so now we know that how we can make it positive or negative. So now if we try to regulate the voltage, so what will happen? Suppose we have two intensities of light. Okay, one is I2, and one is I1, Okay, I2, the photocurrent is N2, I2, N1. Now we know frequency of light are same. Okay, so now if we try to change the sign, okay, here if we change the sign, negative voltage. Okay, this is negative voltage. So with the help of rheostat or battery, we can change the sign. Okay, so now if we try to stop the electron and we try to put the negative voltage, that electron will come here and it will emerge into same point. Okay, because the frequencies are same. If frequencies are same, then when we are trying to reduce, here intensity are different but frequency are same, that's why they are coming at the same point. Okay, so this is called now energy of photon. So this is called applied change. Okay, here we are applying the applied change voltage of collector plate. Okay, here if we are applying change, this is the voltage of collector plate. Okay, this collector plate. Okay, now first it was the current going in that direction. Now we have reversed the voltage. Now the electron will start going to the back direction. Okay, now it will not stop. Okay, now it will stop when here the frequency is changed. Okay, then the photocurrent will stop. Now we know that if we do the zero charge, okay, here we applied the zero voltage, then electron will not stop. Okay, electron will have some velocity, so it will cover. Now we have to apply the opposite charge. Now till how opposite charge we have to apply, this is called retarding voltage. Okay, this is called retarding voltage. So that's how opposite we have to charge we have to apply. With the retarding voltage is same when the frequencies are same. So now if we calculate the energy of photon, now how the energy of photon is calculated? We know energy of photon is given by E equals to hc by lambda. A equals to hc by lambda, and we know 1 electron volt equals to 1.6 into 10 to the power minus 19 joule. Now E in electron volt, we say it is 1242 divided by lambda in nanometer. So this is the shortcut. Whenever you have given the lambda, how you can calculate energy in electron volt, or we can write it as a 1240 divided by lambda in nanometer. So that's how we calculate the energy of a photon in electron volt.